Good evening, one and all. This is going to be the lecture number 27 in hybrid electric vehicle course. Actually, hybrid electric vehicle is now the topic then we are going to see. Actually, we are seeing in module number 4. And in this module, actually, there were two parts. One was the electric vehicle, which we have completed. In hybrid electric vehicle also, which is the second part of module 4, two lectures have been completed. Today we are going to see parallel hybrid electric drivetrains. So in the second part of module 4, that is hybrid electric vehicle, there were mainly 4 topics. We are doing it from the book of Ehsani, chapter number 6, page number 119. In the hybrid electric vehicle, we have seen initially the concept of hybrid electric drivetrains. So there were some different configurations. Then we have seen high architectures of hybrid electric drivetrains. There were some different modes of power transmission. Yesterday we have seen series hybrid electric drivetrain. There we have found that there is electrical coupling which is working for series hybrid electric drivetrain. Today we are going to see the last topic in module 4. Under hybrid electric vehicles, we are going to see parallel type of hybrid electric drivetrain. So in the first 4-5 lectures, the parallel hybrid electric drivetrain topic will be over, because already we have seen in case of series hybrid electric drivetrain, that is, there is a engine which is driven by fossil fuel that is generating some kind of mechanical output, that is engine output, and that is a primary energy source. Then there is a high specific power source which is called as a secondary energy source. These two are mixed in case of series hybrid electric drivetrain, so their output powers are mixed through electrical coupling. In case of parallel hybrid electric drivetrain, this diagram was shown to you previously. We are finding that the primary source is fuel tank. This can be petrol, this can be diesel, fossil fuel. This fuel tank is giving its hydraulic fuel to the IC engine. It's a normal IC engine which is generating rotation, that is a mechanical output at its output, which is going to the mechanical coupler. Yesterday in series hybrid we had found that this IC engine output was getting connected to another generator. Generator was getting input as the mechanical input, it was producing electrical output. So depending on the type of output motor, output of the generator could be AC, could be DC. In parallel hybrid electric drivetrain, actually that biggest constraint of series hybrid electric drivetrain, which is a generator, that constraint is removed. So we are not coupling the electrical energy. Instead, in case of parallel hybrid electric drivetrain, we are coupling mechanical energy directly. But problem is coming in case of the secondary source. Secondary source is a battery which is generally designed in such a way that it should be able to supply the bumper power, or it should be able to supply the high specific power output. Normal battery, generally it is a high specific energy source, but this battery, whatever is connected here in case of HEV, they are designed in such a way that in very small time they should be able to give very high power. So they will be functioning mainly for 10-15 minutes and will get discharged. So this battery is designed specifically for as a high specific power source. So output of the battery, which is electrical in nature, so we are finding that in this diagram also the same convention is followed. Double line is for mechanical link, single line, thin single line is for hydraulic link, which is nothing but output of fuel from the fuel tank to the IC engine, and dark single line is electrical link. So battery, which is a high specific power source, from there electrical energy is going to the power converter. Depending on the type of the motor, DC or AC, power converter is generating DC or AC electrical signal that is actually driving the electric motor. And whenever it's a motor, we know that input is electrical, output is mechanical. So there are two mechanical outputs we are finding, one from the primary source, that is from the engine, another is from the battery after conversions, which is nothing but also mechanical power source. So these two mechanical sources are getting coupled at the mechanical coupler. So basic difference between series hybrid and parallel hybrid is in electrical coupling is being used in case of series hybrid. In case of parallel hybrid, actually there is a mechanical coupling. Now this mechanical coupling will be of two types. Either it can be speed coupling or it can be torque coupling. So within 3-4 slides, this parallel hybrid electric drivetrain explanation will be over. Then we'll dig deep into this mechanical coupler. So we are going to see speed coupling, torque coupling, all those things we are going to see, and all they are actually a part of your exam. So in end-sem exam they will be asked. Anyways, so after the mechanical coupling, we are generating a mechanical output from the mechanical coupler, and that will go to the transmission. So there may be a differential, it will go to the wheel and all those things. So basic difference between series hybrid and parallel hybrid are two. One difference is in series hybrid there is a generator. In case of parallel hybrid there is no generator. So this drivetrain is comparatively lighter than series hybrid. Second basic difference is in series hybrid we are using electrical coupling, in parallel hybrid we are using mechanical coupling. So figure shows the configuration that is traditionally called as parallel hybrid electric drivetrain. The key of this configuration is that two mechanical powers are added together by means of a mechanical coupler. Here IC engine is the primary power plant and the batteries and electric motor drive. They constitute the energy bumper or in need. That means when too much of energy is required, primary and secondary will work together. At that time, high power generated by the secondary power source is called as a bumper power. So battery is acting as a secondary or bumper power source here. Power flows can be controlled only by the power plants, and engine and the electric motor, all those things can be controlled so that the output of mechanical power, mechanical coupler will get controlled. So we have to control the IC engine parameters, we have to control the electric motor parameters. Hence the input to the mechanical coupler will be controlled, and in the same process output of mechanical coupler also will be controlled. So in the exam, if I am asking a 10-mark question only on parallel hybrid electric drivetrain, this is the diagram you have to draw. Same thing was told in case of series hybrid also. But if I am asking parallel hybrid electric drivetrain only for 5 marks, in that case explain this smaller diagram. So this is a detailed diagram for mechanical coupling or parallel hybrid electric drivetrain. So it is one of the drivetrain in which the engine supplies its mechanical power directly to the drive wheels. You can find here that engine, whenever this secondary, that is this battery thing is suppose cut off, you are finding that fuel tank is giving hydraulic chemical to the engine, that is the gasoline or petrol. Output of engine is mechanical power getting coupled with the mechanical coupler. Through the mechanical transmission, differential and all, it is directly going to the final drive element and differential. So what we find here is, in case of parallel hybrid drivetrain, engine supplies mechanical power, which is the natural output of engine or IC engine. So directly the mechanical power can be fed to the output of the transmission system or to the input of the wheel. The engine is assisted by an electric motor during the very high requirement of power. At that time engine and electric motor or battery, they act together. So engine is assisted by an electric motor. That is what it is saying. So electric motor is the element of secondary powertrain. Engine is the main element of the primary powertrain. So whenever too much of demand of power, at that time engine and electric motor together, they actually generate the mechanical output. So that mechanical output is from each stage is actually getting coupled in the mechanical coupler. Powers of the engine and motors are coupled together by the mechanical coupling. I told you there are two types of coupling, speed coupling, torque coupling. We will see that. Distinguishing feature of this architecture is that two mechanical powers from the engine and electric motor are added together by a mechanical power. So this is one distinguishing feature, and second feature is there is no generator here. Generator actually converts the mechanical power into electrical power. So that was required in case of series hybrid because it was coupling the electrical power. Parallel hybrid means it is mechanical coupling. That's why there is no generator in this case. But one thing you will be finding that whatever were the different charging methods for the battery, here also all those three types of charging we can find for the secondary power source or battery. So what is the first charging method? That is this battery stack is directly getting charged by the external battery charger. That is the first way of charging the battery. Second is this engine will indirectly, that means through the mechanical coupler, through the motor controller and all, they will send some power to the battery stack. So this is the second way of charging the battery. So this we found in case of first, that is series hybrid electric drivetrain also, that is primary source was charging the secondary source. In this case also the same thing happens, that is engine, mechanical coupler, then motor controller, and power might come back to the battery. So this is the second way of charging the battery. And third way is the ever conventional way, that is regenerative braking. So whenever the vehicle is going into the braking situation, at that time the output actually gives mechanical power back to the input. So at that time the machine mechanical coupler, it gives power back to the motor, which acts as a generator at that time. This motor controller can be a bidirectional controller, and it will be coming to the battery. So all these three types of charging of the secondary device, that is battery, what we found in case of series hybrid, the same three types of charging we will find in case of parallel driving as well. What are the advantages of parallel hybrid electric drivetrain? So all the possible operating modes mentioned in the series hybrid are still effective. So there were 9 modes, all 9 modes are possible in case of parallel hybrid. More advantages of parallel hybrid drivetrain over series hybrid drivetrain are both the engine and electric motor directly supply the torques to the drive wheel. So you are finding here in this case mainly we are generating mechanical output from the primary source as well as from the secondary source, and the mechanical vehicle, which is a vehicle is a mechanical device, this also requires mechanical energy. So in this case generation is also mechanical energy and requirement is also mechanical energy. So there is a positive. So this is a kind of a proper alignment. So no energy conversion from engine to electrical energy, electrical to mechanical energy. So which was happening in case of series hybrid. So there were 2-3 types of conversion. That thing is avoided here. So the first advantage is both the engine and electric motor directly supplies torque, that is mechanical torque to the drive wheel, and no energy form conversion occurs mainly in the primary source. So as we are avoiding the energy conversion in the primary source, we are actually saving some power, because in generator in case of series hybrid lot of power gets wasted. So there are two steps of power conversion in case of series hybrid. In parallel hybrid actually we have avoided the use of generator, and we are saving some power. Second advantage, parallel hybrid is more compact because there is no additional generator. Traction motor is smaller in size than the series. So you will say like, okay, sir, there is no generator, but the motor has come in series with the secondary source. Yes, motor was there in previous case also. In case of a series hybrid also motor was there. In parallel hybrid also motor is there. And good thing is in case of parallel hybrid the motor is much smaller in size. So smaller motor size means smaller power loss. So that is what it is mentioned in the second point here in the advantage, that is parallel hybrid the motor is much more compact. Traction motor is actually smaller than series hybrid in this case. So these are the two main advantages apart from all the advantages of series hybrid. Disadvantages of parallel hybrid, the mechanical coupling between the engine and drive wheel is found since the engine operating points cannot be fixed in a narrow speed and torque region, because it is difficult to control mechanical coupling and its characteristic within very narrow speed and torque region. So amount of error in speed control of this overall drivetrain as well as the primary powertrain, very narrow range speed control or very accurate speed control is not possible, because it is mechanical kind of coupling and mechanical systems are always little less accurate than the electrical system. So that's why we are finding in case of series hybrid it was electrical always. That's why the control was very precise speed control and torque control. In the secondary type, which is a parallel hybrid type, which is a mechanical coupling, we are mainly controlling the mechanical power. In this case the operating points cannot be fixed or cannot be controlled within a very narrow error region. So this is one disadvantage of parallel hybrid, but then also it is considerably correct. So it cannot be controlled within very narrow region, but yes, within narrow region it can be controlled. And what we are finding is, because of complexity of the mechanical processes, parallel hybrid is a little more complex than the series hybrid. What are the different types of parallel hybrid? So up till this slide number 5, it was very easy. We have seen it previously also. Now onwards it will be a little more mechanical engineering extensive, so try to understand. Here from slide 6 onwards till the end, so 8-9 slides are there, which are all about parallel hybrid electric drivetrain and their types. So there are mainly two types of coupling we have found. One is torque coupling, one is speed coupling. So in torque coupling, the mechanical coupler adds the torque from engine and from the motor. So engine is also generating mechanical force, motor is also generating mechanical force. So in case of torque coupling, the torques from engine and electric motor is getting combined. And similarly in speed coupling, the speed from engine and motor is getting combined. So the engine and motor torque can be independently controlled. So that means primary source and secondary source of torque can be controlled separately. But the speeds of the engine, the motor and the vehicle are linked together in a fixed relationship and cannot be independently controlled because of the power conservation constraint. So this is a control problem you are finding. The engine and motor torque can be independently controlled. So engine is primary source, motor is the secondary source, but speed of the engine, speed of the motor and speed of the vehicle, they are linked together in a fixed relationship and cannot be independently controlled because of the power conservation constraint. So this is actually what is called as a torque coupling. So in case of torque coupling, primary source, secondary source, their torque is added together and given to the final stage, that is mechanical power transmission and wheel. Whereas in case of speed coupling, the speed of the engine and motor can be added together directly. So all the torques are linked together and cannot be independently controlled. So whatever you do, even if you are adding the speed, even if you are adding the torque, but we are finding that there is a fixed relationship between the speed and torque of three things, that is engine, motor and the vehicle. So whatever you do, speed control and torque control, they are actually a complex type of control in case of parallel hybrid. So first we are finding the torque coupling. In case of torque coupling, we are finding port 1. This port 1 is actually unidirectional because T1 and omega 1. So omega 1 is the output rotational speed of engine. T1 is the rotational torque of the engine, that is IC engine. That's why it is unidirectional, because no power goes back towards the engine. It is unidirectional, and this is the mechanical torque coupling. I told you that parallel hybrid uses two types of coupling, series and parallel. One is a torque coupling, one is speed coupling. So this is the first type, which is called as a torque coupling device. So port 2, which is nothing but the battery. So here you are finding the power is bidirectional, because in the forward driving, the battery actually is giving mechanical power, battery giving electrical power that is getting converted to mechanical power by motor, and that motor output power is coupled to the mechanical torque coupling. But in regenerative braking, we are finding from the output side through the torque coupling, power is coming back to the battery. That's why this arrow is bidirectional. So whenever the battery is producing the output of motor torque in the secondary powertrain, at that time the motor torque is T2 and motor output speed is omega 2. So in this case, T1 and T2 is getting combined and it is actually producing T3. So what is meant by torque coupling? T1 and T2 is getting added. But in that case, we find a relationship between omega 1, omega 2 and omega 3. So this port 3 is actually mechanical transmission, which is connected to the wheel, and T3 is actually a combination of T1 and T2, and omega 1, omega 2, omega 3, they are also somehow related. So figure shows a mechanical torque coupling in two ports. Port 1 is the unidirectional input from the engine, IC engine. Port 2 and 3 are bidirectional, because port 2 is the battery source and port 3 is the output transmission. So during forward transmission in port 3, the arrow should be rightward. In regenerative braking in port 3, the arrow should be leftward. So this port 3 is nothing but the output port which is connected to the transmission and wheel system. Here the input means the energy flow into the device, output means the energy flow out of the device. In a hybrid electric vehicle application, the port 1 is connected to IC engine directly or through a mechanical transmission. Port 2 is connected to a shaft of an electric motor. That motor is actually powered by the battery. Port 3 is connected to the drive wheels through a mechanical linkage. Drivetrain characteristics with torque coupling. So here you are finding that engine torque characteristic. So x-axis is omega e, nothing but engine rotational speed. Y-axis is Te, that is nothing but the engine torque. So here you are finding almost kind of a flat characteristic. That means with increment in the speed, we are finding initially the speed is torque is considerably okay for lower speed. Then in the mid speed range, rotational speed, the torque is kind of a peak, and then torque is dropping with increment in the motor speed. But then also we are finding that torque from the engine is almost kind of a flattish kind of a character. And engine is having clutch at its output. So clutch is actually connecting the engine power to the transmission 1 or to the torque coupler. There is a battery which is a secondary source. Through the motor controller it is connected to the motor, and we are finding the motor characteristic. We have seen this characteristic many times. Initially there is a constant region up to base speed, x-axis is speed. So till base speed the output torque is constant, and this torque is considerably high. After this base speed we are finding the speed is increasing because kind of gear is increasing, speed is increasing. Power is, let's say, a constant power region, but the torque will be reducing after the base speed. So this characteristic of engine and this characteristic of motor, they are actually added together, and whatever is the addition you can assume what will be the addition. So battery, motor controller, motor, transmission 2. Transmission 2 means this is a powertrain 2. Transmission 1 is powertrain 1. We are finding there is a clutch. That means we are actually changing the gear ratio of the engine and how much power to be connected to the transmission 1, that we can control by clutch gear mechanism. And here this is torque coupling. That means T1 and T2 is getting added here, and there is produced a T3 which is nothing but a mechanical power which is connected to the wheels by differential. So torque coupler can be used. So this is actually the torque coupling. After the transmission 1 and transmission 2, this kind of vertical block is called as a torque coupling block. It constitutes hybrid drivetrain with many different configurations. Based on the torque coupler used, a 2 shaft or 1 shaft configuration may be designed. Transmission may be placed in different positions with different gears, in each case resulting in various tractive characteristics. So if we change this clutch, obviously the power transmission from the engine to the transmission 1 it changes, and depending on that the power transmitted to the differential also changes. So depending on the clutch position we can have different power transmitted to the wheels. A good design depends mostly on the tractive requirement, engine size, motor speed torque characteristics, etc. Figure in the right shows a 2 shaft configuration in which 2 transmissions are used. So in this case we are finding transmission 1 is engine, transmission 2 is motor. So this is a 2 transmission system, and the variables are tractive requirement, that means how much power the vehicle requires to run itself to satisfy the driver. So for that the road and the drive cycle is also very important. So how much power is required by the vehicle to drive through any drive cycle, that is the first requirement or first parameter for any kind of drivetrain design. Engine size is very important, motor size is also very important, and we have found out that in case of parallel hybrid drivetrain, motor size is comparatively smaller compared to the series hybrid drivetrain. And motor speed torque characteristic. So motor is actually driven by the battery, but there is a motor controller as well. So battery, motor controller, motor, this is the second link or second powertrain, and through the transmission 2 it is coupled with the torque coupler. So 1 is placed between the engine and the torque coupler. So transmission 1 is placed in between engine and the torque coupler, and the transmission 2 it is placed between the motor and the torque coupler. Both transmission may be single gear or multi gear. Generally here it is shown that engine transmission is multi gear, and here motor transmission or electrical transmission is single gear. But if requirement be, the motor transmission can also be connected with some kind of manual or automatic clutch. So the last line is important. Both transmissions may be single gear or multi-gear. So in this case, the same diagram is there. It is called as a two shaft configuration because there are two sources, engine and transmission 1, motor and transmission 2. That's why it's called as a two shaft configuration. So as shown in the figure, multi-gear transmission 1, that is engine transmission, single gear transmission 2 may be used. But if requirement be, motor can also be made single gear. Referring to the relative position of transmissions and the electric motor, configuration is referred to a pre-transmission configuration. So this configuration where we are putting clutch in the engine and no clutch in the motor or no gear in the motor, this is called as a pre-transmission configuration. Why? Because the electric motor is in front of the transmission 2. So this transmission 2, motor is ahead of the transmission. That's why it is called as a pre-transmission configuration. So first there is coming the motor, then there is coming the transmission. That's why it is called as a pre-transmission. Whether in case of series hybrid electric, if you remember, there was a motor first and then there was a coupling. After that there was a transmission, so it was called as a post-transmission. So in this case, transmission is first and then there is a motor is first and then there is a transmission. That's why it is called as a pre-transmission. Two multi-gear transmission produce many tractive effort profiles. Performance and overall efficiency of the drivetrain is superior here compared to the other designs. So what claim is torque coupling is a lot better. Two multi-gear provide more opportunities for both the engines and the electric traction system. Two multi-gear means engine is also connected with clutch gear, motor is also connected with clutch gear. So clutch gear is actually giving us more opportunity for control, but to operate optimum region. So if there are two multi-gear transmission, that means engine as well as motor, it might provide more opportunities for both the engine and the electric traction system, that is electric machine and battery, to operate in optimal region. Optimal region means maximum efficiency. So efficiency maximization is another very important task in case of any kind of drivetrain. This design also provides great flexibility in engine design and electric motor characteristics, but so there is a very big but. Two multi-gear transmission will significantly complicate the drivetrain and increase the burden of the control system for selecting the proper gear in each transmission. Generally, you might not have seen any vehicle with two clutches. So in this case, if we could put another clutch after the motor, in that case, while driving a HEV, we have to control two clutches, one clutch for engine and the clutch for motor, and generally it is very cumbersome and it is very complex. So though putting another clutch with motor would have given us a better control or finer control, but we don't do that because in that case the multi-gear transmission will significantly complicate the drivetrain and driver will get irritated because he had to control in that case two different clutches. It will increase the burden of the control system for selecting the proper gear in each transmission and driver's job will become difficult. What is the drivetrain characteristic with torque coupling? So if it's a 3-gear system, you are finding that the initial torque is quite less. So don't get confused or don't get scared looking at this diagram. All these diagrams we have actually seen previously in case of electric vehicle. So if it's a 3-gear transmission, in that case you are finding the initial torque is quite less. If it's a 1-gear transmission, you are finding the initial torque is very high. So it is around 6.5 to 7 kilonewton. So this is the first gear system. Initial torque is very high. Second gear system, that means 2-gear system, initial torque is in between 5000 to 6000. If it is a 3-gear system, initial torque reduces. And you are finding that if it's a 1-gear system, the higher speed or higher side speed is quite considerable and the decrement in the torque is quite high. So you are finding that in case of gear 1, the fall in the torque is quite high or quite abrupt, whereas in case of 3-gear system, the fall is kind of a flattish. Okay, so that you are finding. So this is multi-gear engine transmission and single gear motor transmission. So in this case you are finding it's a combination of multi-gear engine transmission and single gear motor transmission. So in this case, engine and motor, both gear we have kept together. So this is first gear of transmission 1. First gear of transmission 1 means this is engine or generator gear 1. This is second gear of transmission 1. This is third gear of transmission 1. That means this is simple IC engine based vehicle only. Okay. And here 1 gear of transmission 2 and 3 gears of transmission 1. So this is a different combination. You just keep on reading this, you will understand. And what are the base speed, what are the maximum speed, all these things are given here. Tractive effort speed profiles is shown in figure here in the region of a hybrid drivetrain. So why is it called hybrid? Because there is gasoline or fossil fuel based engine transmission, as well as there is electric battery transmission. So they are being used together, that's why this is called as a hybrid. So in the tractive effort speed profile means tractive effort versus tractive effort is in the y-axis and speed in the x-axis. So in the tractive effort speed profile shown in figure here, in the design of hybrid drivetrain, the maximum tractive effort with this transmission arrangement may be sufficient for hill climbing performance. Greater is the tractive effort would not be needed because the limitation of the tire ground contact adhesion. Utilizing a single gear transmission 2. That means transmission 2 is having single gear. Transmission 2 is nothing but a gear connected to the motor in the powertrain 2. So I told you it's a mixed kind of a thing. There's a torque coupling. So in this case actually for battery or for the second powertrain, 1 gear we have kept, and for primary, that is engine thing or IC engine thing, we have kept 3 gears. So it is written here 3 gears of transmission 1 and 1 gear of transmission 2. Below are characteristic of all 3 gears of transmission 1, and that 1 gear of transmission 2 is always there. Motor speed ratio is equal to x is equal to 4. That means maximum speed versus base speed of highest gear is equal to 4. So you are finding that motor speed is maximum is around 150, and as motor speed ratio is x is equal to 4. That means highest base speed in case of first source is 150 by 4, so that is around 35 to 40 km per hour. Utilizing a single gear transmission 2 takes advantage of the high torque of an electric machine at the low speed. So you are finding here multi-gear transmission 1 is used to overcome the disadvantage of IC engine speed torque characteristic, which is actually a flattish characteristic. So multi-gear transmission 1 also tends to improve the operating efficiency and engine and reduces the speed range of the vehicle in which electrical machine must propel to the vehicle alone, thus preventing the battery from quickly discharging. So initial part we are actually starting the first gear of multi-gear engine gear system, and as the speed is increasing, as the vehicle is going into the constant power region, then we can switch to the secondary power source or first gear of transmission 2. So initially we are starting with first gear of transmission 1, that is the engine, and then when the vehicle speeds up, at that time we are shifting it to the first gear of transmission 2. Here is another combination. Here first gear of transmission 1 and 3 gears of transmission 2 with a motor speed ratio of x is equal to 2. So you just go through, because this is single gear engine transmission and multi-gear motor transmission. So previous case we found multi-gear engine transmission and single gear motor transmission. You are finding here 3 gears of transmission 1, that is the engine, and 1 gear of transmission 2. In the next we are seeing that single gear engine transmission, that means engine is having only 1 gear, and transmission 2, that is motor, that is a battery driven thing, it is having 3 gears, and there the 3 gear characteristic is different, but still the lowest gear is having highest tractive effort. So in this case you are finding the 3 gear tractive effort for IC engine, and below you are finding the 3 gear tractive effort for the secondary power system, that is battery driven motor system. So you are finding here first gear, second gear, and third gear of transmission 2, and here you are finding very small, this is the first gear of first transmission system. So how to combine them and what are the examples, what are the discussion you can find here. This is a system where first gear of transmission 1 and first gear of transmission 2, here motor speed ratio is x is equal to 4. So in this case there are multi-gear system. So though we have said multi-gear systems are not much sought after, because in this case we have to have too much control of the gears, and generally the driver gets irritated controlling two gears. So all the slides will not be asked. So whatever I have shown, so from this slide onwards, slide number 8, okay, whatever I have explained from slide number 8, 9 and 10, okay, 8, 9 and 10, you can check these numbers, okay, slide number 8, 9, 10. This will not be asked in the exam. So this is slide number 8, number is here, or whatever is here, slide number 9, or whatever is shown here, slide number 10. So these three slides will not be asked in the final exam, but yes, they may be asked in the IE. So you can prepare this for IE but not for the final exam. So what is this slide number 8, 9, 10 about? Slide number 8, 9, 10 is about putting multi-gear system or putting gear for both electrical drive or electrical generation powertrain as well as mechanical generation powertrain. Electrical generation powertrain means the battery, the motor controller and the motor, which is actually producing the mechanical output power, and the transmission 1 or powertrain 1 is actually a engine which is driven by the fuel tank. So for both of them we are putting some kind of gear system. So when the first gear of transmission 1, that is first gear is from the engine, and first gear of transmission 2, that is from the battery and motor, whenever they are used as a combination to drive a parallel hybrid electric vehicle, at that time what is the tractive effort versus speed characteristic. So both single gear engine transmission, in that case you are finding net tractive effort has reduced. So previous both the cases you would find that the tractive effort is around 6000 here. In the previous case tractive effort is most, that is around 6500. But whenever we are using single gear transmission 1, single gear transmission 2, in that case we are finding the tractive effort is actually comparatively less. It is coming to be 5000 Newton or 5 kilonewton. So this arrangement results in a comparatively simpler configuration. This is the advantage of this one gear transmission 1 and one gear transmission 2, or both single gear engine transmission with motor speed ratio x is equal to 4. So you are finding maximum speed is around 160. That means maximum base speed is around 160 by 4, that is around 40 km per hour. So what is the advantage of this? You are finding in both the transmissions only first gear we are taking. So this is a very simpler kind of arrangement. Limitation of this application of this drivetrain is that maximum tractive effort and drivetrain. So you are finding, I told you that the highest tractive effort is less, it is around 5 kN. When the power ratings of the engine, electric motor, batteries and transmission parameters are properly designed, this drivetrain gives the vehicle satisfactory performance and efficiency. So design consideration has to be very properly done in case of single gear, in case of both transmissions. Otherwise in the previous two cases the power was high. In this case, that is when both single gear transmissions are used, in this case the design has to be perfect to satisfy the vehicle drive characteristics. So all these things so far was about torque coupling, where we are actually coupling the torque from the engine as well as torque from the motor. So torque from the engine was being called as a transmission 1, torque from motor is being called as a transmission 2. Their output was coupled during the torque coupling, and output is mechanical, which is given to the differential and transmission system, and it was being given to the wheel. So this was torque coupling, which is a part of parallel hybrid drivetrain. Next what we are going to see, so only two slides are there, this slide and the next slide. Next we are going to see speed coupling. So what is the speed coupling we are finding? So mechanical speed coupler has the property omega 3, that means this is the speed given to the transmission, that is equal to k1 omega 1. Omega 1 is the speed of the engine, and k2 omega 2. Omega 2 is the speed of the electrically driven motor, and there are proportionally constant k1 and k2. So it is not direct addition, speed is not direct addition, it is a scaled addition. We are assigning some weight of k1 and k2 in front of the angular speed of engine as well as for motor. So W3 is k1 omega 1 plus k2 omega 2. This is the property of the mechanical speed coupler. So powers produced by the two power plants, engine and motor, may be coupled together by adding their speeds as shown in the figure. The figure is given below. So here you are finding speed coupling device. So this is the speed coupler, port 2 generating omega 2, port 1 generating omega 1. So this omega 3 at port 3, which is a transmission and differential, omega 3 is equal to k1 omega 1 plus k2 omega 2. So similar to the mechanical torque coupler, the speed coupler is also a 3-port mechanical device. You are finding here this is a 3-port. One is input port, one is unidirectional port, and other two are bidirectional port. So port T1 and T2, they are actually input port. Port T3 is actually the output port, but during regeneration T3 also acts as an input port and T2 acts as an output port. So this is applicable for both speed coupling as well as torque coupling. So similar to the mechanical torque coupler, the speed coupler is also a 3-port mechanical device. Port 1 may be connected to an IC engine, which is unidirectional. Port 2 and 3 may be connected to electric motor and to the load. Load is nothing but final drive. This is T3 omega 3. And port 2 and port 3, they are both bidirectional port. So in this case, you are finding from the engine, this is a transmission. It is coming to lock 1. And then it is going to the lock 2. What is lock? We will discuss in the next slide. And battery, motor controller, motor, and again it is coming to the lock 1 and lock 2. So what are the jobs of the lock? We are going to find, and you find that this mechanical structure is little complicated than the previous structure. So what was the previous structure for torque coupling? Directly you can see there, this is a torque coupling structure. This is comparatively easier looking. But if you see to the slide number 13, you'll be finding that the speed coupler actually is much more complicated structure, which is a mechanical structure also, and there are certain locks. Actually, what are the locks doing? We are going to see in the next slide. So this is hybrid electric drivetrain with speed coupling of a planetary gear unit. So this coupling is being done by a planetary gear. So you have seen sun gear, pinion gear, all those gears we have seen while we had been studying the final drive element or differential. So all that thing is connected here, or that sun gear or planetary gear, they are actually shown here, and through that actually we are coupling the speed. So here it is transmission. There is no transmission here shown. So there is a clutch here. So here we are actually controlling the speed or torque of the vehicle or engine. So there is a clutch in the primary transmission thing, and there is no clutch in the secondary. So for battery motor, no clutch is shown here. So there is electric hybrid drivetrain with a speed coupling of a planetary gear unit. So one speed is given here. You can see that the primary speed is given to the shaft, and the secondary speed is connected to the outer side of the gear system. So little understanding we will have from this regarding this lock and other thing. So hybrid electric drivetrain with speed coupling of a planetary gear units. So this can be asked for a 5 marks question. You can draw a block diagram, but yes, this lock 1, lock 2 and this planetary gear system you have to draw properly, because that is only the new thing here in speed coupling. Other things are very easy. So this clutch also you can just show by a small block diagram. You don't have to draw like this. So engine, clutch, transmission, battery, motor controller, motor. After that there are the sun gear systems and all. Transmission 1 is connected to the shaft. This is the axle, and it goes to the differential, then the wheel. Let us just go through this paragraph and we will finish this lecture and this module. So similar to the torque coupling device, speed coupling units can be used to constitute various hybrid drivetrains. Figure shows an example of a hybrid drivetrain with speed coupling using a planetary gear unit. So this right side, this part is a planetary gear unit. Here the engine supplies its power to the sun gear through a clutch and different transmission. So here is a clutch and here is a transmission system through which engine power goes to the gear system. Transmission is used to modify the speed torque profile of the engine to match the traction requirement. So this transmission is kind of a control. Actually this transmission is used to modify the speed torque profile of the engine to match the traction requirement. That means whatever are the torque and speed required by the vehicle for going up to the hill or going through a high acceleration. So that requirement is actually posed to this speed coupler. And this line is very important. Transmission is used to modify the speed torque profile of the engine to match the traction requirement. So traction requirement is coming from the vehicle tire, traction requirement is coming from the driver, and whatever power is generated by the engine and batteries depending on the traction requirement from the driver. That actually will be connected to this gear system or planetary gear system. Transmission may be multi-gear or single gear. That means either you can put clutch in engine and this motor as well, or you can put clutch only in engine. That is called as a single gear system. So the transmission may be multi-gear or single gear based on the engine speed torque profile. Electric motor supplies its power to the ring gear through a pair of gears, lock 1 and lock 2. So what are the jobs of these two? This you have to explain clearly. So lock 1 and lock 2 are used to lock the sun gear and the ring gear to the stationary frame of a vehicle in order to implement the different operational mode. So lock 1 is actually the lock for sun gear and lock 2 is actually the lock for ring gear. So these two are actually attaching the gears to the frame of the vehicle in order to implement the different operational modes. So these are actually the controller of the coupling. So coupling quality between the gear and the ring gear and the whole power generation system, they are actually ensured by lock 1 and lock 2. So very important thing, lock 1 is actually used to lock the sun gear, lock 2 is used to lock the ring gear to the stationary frame of the vehicle in order to implement the different operational mode, because these gears are actually rotating parts and vehicle chassis is actually a static part. So this lock 1 and lock 2 couples this rotating part with the fixed part of the chassis. Last line is very important. Lock 1 and lock 2 are used to lock the sun gear and the ring gear to the stationary frame of the vehicle in order to implement different operational modes. So this is the diagram of a hybrid electric drivetrain with speed coupling of a planetary gear unit. So this right side with lock 1, lock 2, it looks little complicated, but with little practice I think you will be able to pick up this diagram, and you have to show this diagram in the exam also. Okay, so this speed coupling and torque coupling, it can be asked in the exam block diagram point of view, but remember that this slide number 8, 9 and 10, this characteristics, okay, 7 can be asked in the exam, but 8, 9 and 10 you just know this, what are the complexity of the gear, because there are two gear system, one is for engine and another is for the motor. So this characteristics will not be asked in the NSEM exam, but they may be asked in the IA. And after this, that is slide number 13 and 14, that is speed coupling. Yes, it can be asked in both IA as well as in final NSEM exam. So here finishes the parallel hybrid drivetrain with speed coupling, torque coupling with the basic block diagram. So here we finish the hybrid electric vehicle. There were mainly 4 topics. As we had seen, the 4 topics were comprising, the first topic was hybrid electric drivetrain, concept of hybrid electric drivetrain. This was the basic concept. Then there was architecture of HEV drivetrain. There was series hybrid electric drivetrain and parallel hybrid electric drivetrain. So whatever has been taught so far, you prepare this much for your NSEM exam, for your IA, IA2. IA syllabus will be module 3 and module 4. So here I declare module number 4. We are going to start with more detailed discussion on hybrid electric vehicle in module 5. So module 5 will be started tomorrow. Good night. Thank you all.